Hello, this is Mr. Edwards, and today we will be calculating limits using the limit laws. Now, if we're given two functions, f of x and g of x, and we're given that the limit of x as x approaches a of f of x, and then we have the limit of as x approaches a of g of x as just two functions, there are 5 laws that we can apply in order to work out and how to calculate limits using these laws. Now, the 5 laws are the sum, difference, constant multiplication, product, and quotient. What it says is that if we have the limit of the functions f plus g, the limit of the sum of two functions is the sum of the limits of the two functions. That is, the limit of f plus g is the limit of f plus the limit of g. And for differences, for subtraction, the limit of the difference of two functions is equal to the difference of the limits. Here, rule number 3, this is constant multiplication. If c is a constant number and f is one of these functions, the limit of the constant times the function is equal to the c essentially factored out of the function times the limit of the function. The 4th law is the product rule, which simply says that the limit of the product of two functions, if f and g are being multiplied together, is equal to the product of the limits, limit of f times the limit of g. And finally, the quotient rule says that if we have the limit of the quotient of two functions, f divided by g, that's equal to the quotient of the limits, the limit of f divided by the limit of g, provided that the limit of g does not equal 0, so we don't have the problem of having to divide by 0. Now, there are 2 corollaries to these 5 laws above, and a corollary is just simply a law that follows from the laws above it. Here is the power law, which says that the limit of a function raised to the nth power is equal to the nth power of the limit of the function. And with taking roots like square root or cube root, the limit of the nth root of a function is equal to the nth root of the limit of the function. I'll give you some time to look at these 5 laws and the 2 corollaries. Okay. Now, we come to 3 special limits, which are fairly obvious, but we should go over them. It says that if you have a constant number c, and let's say a function y equals 7, for example, a horizontal line, the limit of the function c as x approaches a is always going to be c because the function is always c. Similarly, in the second one here, if we have the function x, y equals x, that's graphed as a diagonal line going up with the right with a slope of 1, then the limit of the function x as x approaches a is simply a. Since y equals x, a equals a. And the third one follows from this is that if we take the function x to the nth power and we look for the limit as x approaches a, it is a raised to the nth power. Now we come to direct substitution and continuity. Now, if f of x is a polynomial or a rational function with a in the domain, then the limit as x approaches a of f of x is simply the value of the function at that point a, and that equals the limit. Let's look on the graph here. Here is, let's say, a polynomial function. What it says is that if I approach this, here's a. If I approach the limit as f of x as x approaches a of the function from below, or I approach it from above, from the right, it is, in this case, it is equal. The limit is equal to the value of the function at that point. And from this, we can say that the function is continuous at point A. That's the point we're interested in. So this is a case where the limit around A is L, and the function value at A is also equal to L. That means that if you have a polynomial like x cubed plus 5x squared plus x, if you want to find the limit of that polynomial at the point A, you simply plug in A by direct substitution, and that will give you the value. Okay, now we have three theorems here to look at, and this one you've already seen before. It says that this is dealing with left and right side limits, or one-sided limits. Here it says the limit as x approaches a of any function x is L if and only if, that's what this stands for, if and only if, the limit of the function as x approaches a from below, that's the negative sign, is L, and that is equal to the limit of the function as x approaches a from the right or from above. Only when both sides of the limit is equal to L is the limit, can we say definitively that the limit of the function as x approaches a is equal to L. Now, the second theorem is fairly obvious, and you really won't get it until we get to the third. What it's saying is that if we have two functions, f of x and g of x, and if f of x is less than or equal to g of x, when x is near a, doesn't say it has to be at a, but in the neighborhood of a, then the limit of the function f as x approaches a, it will be less than or equal to the limit of g of x as x approaches a. Okay, now keep that in mind as we get to number 3, which is called the squeeze theorem. Now, what this says is that if we have three functions, f, g, and h, and f is less than or equal to g is less than or equal to h, right? And this I've illustrated it here. F is less than g is less than h of x. If that's true, and the limit of f as we approach a is equal to the limit of h as we approach a, and that is equal to L, that is to say that if h, see h here has a limit of a is L, the limit of this lower function in black, f, is also a, then the limit of g, the middle function in the green, is also equal to L. And all it means is to say that if you have a sandwich made of this top one h and the lower one f, then you squeeze in the middle, then g of x itself has a limit equal to L. Now, this may not make sense to you right now, but you'll see it in the problems that you'll do. I hope this has been a good survey and introduction into how we can calculate limits using the laws of the limit. See you next time.